continuing with our fertility rate and life expectancy data set. Suppose a country in 1962 had a fertility rate of 4.54 births per woman. Now, again, tie that back to the graph. Fertility rate, births per woman, that's X. So they're telling you, hey, we have a country that has X equal to 4.54. Using the linear equation given on the graph, what would we expect that country's life expectancy to be? So in other words, what's the y, right? The y equals what? Now this is the opposite of the one we just did. So we know that our equation is y hat equals, and I forgot to put the hat on the last one. Whoops. It's not a big deal, but technically it's a y hat. So y hat equals 81.51 minus 4.6711 x. So what we're going to do is we're going to put this value in for x. So we're going to say 81.51 minus 4.6711 times 4.54. We're substituting that value in for x. Okay, so this is going to be very straightforward. This is not nearly as hard as the last one. Solving for x is much harder than solving for y. All we have to do is substitute in. So it's 81.51 take away 4.6711 times 4.54. Or again, if you prefer having the parentheses, that's fine also. Parentheses in this context only means multiplication anyway. So it's fine either way. And we're going to get 60.3. Okay, so 60.3, we'll write that down. Now we have to think about the units on this. Well, this was a country's life expectancy. If I go back and look, life expectancy was a y variable. Right. So this was years. Now, the country of Gabon, which is in Africa, had a birth rate of 4.54 children per woman and a life expectancy of 39.56 years in 1962. Compute, draw, and label the residual, i.e. the error on the graph. Okay, so error doesn't mean you did anything wrong. Error just means you made a prediction and it didn't work out, which it won't for half of the values out here, right? Because it's just how it is. So Gabon is right here. So 4.54 is right there. This is real life Gabon right there. So that was Gabon in reality. So this is Gabon. It's Y. But up here is where we made the prediction. So that's our prediction. So that's Gabon's y hat. The error is the distance between the two. The error is this distance right here, right? It's also called the residual. And if you look, every dot has a residual. Every dot has its real life value here where the dot is, and then a prediction where the line is. There's a whole bunch of predictions on that line. That's what makes the line. So you would compare this dot to its prediction, and this dot to its prediction, and this dot to its prediction, and so on. So every one of these has a residual, right? They're all going to be off a little bit. Okay, so how do we find that residual? Well, it's actually pretty straightforward. The residual, and the formula is down below. You can see it right here. So an error is another word for it, but we will use the word residual almost always. It's the actual y from real life minus the predicted y hat. Okay, so Gabon in 1962 actually had a y value right here. Right? This is the life expectancy. This really is y equals 39.56. This is a y hat value. So the actual y was 39.56 minus the predicted y was 60.3. And if you're interested, they're both years, right? So this is years and this is years. So when you subtract, oh, that years got crammed. Give me 1 second. So years. So when we subtract, we just need to subtract those values and we'll know what it is. So we need to take Desmos and take 39.56, take away 60.3. That'd be negative 20.74. And we'll have the same unit as everything else because it's a distance in y, so it'll be years. That would be the unit. Okay, so interpret Gabon's residual value in the context of the situation. Was it doing well or doing poorly? Okay, well, let's look at the graph. We expected the life expectancy of Gabon to be 60, but it was actually 40, like 39.5. So that's not good, right? You'll notice Gabon is really kind of out here on its own. Gabon in 1962 is having some major upheavals and civil wars and other issues. So Gabon was doing very poorly. Because the life expectancy was way lower than we would have expected. And in general, you want people to live a long time in a country. It was 20.74 years lower than expected. And again, there are some reasons for this. Feel free to go read up on Gabon. It's a lovely and interesting country, right? But it was having some major issues in the 1960s, as was the case of many African countries finding their feet in independence in the independence movement. Okay, so let's think about residuals a little bit more here. So the residual is how off the points are from the line. That's all it is, right? And I don't even know if I wrote that here, but it's how off the points are from the line, or the real life point are from the line. The line is the prediction, right? The real life is the actual, right? So if you want to make a note of that, oops, this is real life, and this is the line that we generally find or is given to us in the problem. It has the same units as the y variable. So that's why ours, for example, ended up with years. So whatever your y variable is, that'll be the unit. The least squares regression model is the model that makes the residuals the smallest. That's what makes this model special. So when we were in section 4.1, we were saying, you can see the line, it's there. That line is the one that makes the residuals the smallest. That's what least squares regression model means. It means it takes the squares of the residuals and minimizes them. So the size of the residual can tell you how well your model is fitting in your situation, right? Smaller residuals mean it's doing a better job. So what does it mean if you have a positive residual versus if you have a negative residual? So let me draw a little picture right here. Actually, I'll draw a picture of kind of a quick sketch of what we have on the first page. So you have a line here. A positive residual would mean the value is higher than expected, right? The real life was higher than the prediction. And that could be a good or a bad thing, right? So the actual y value is above the line. Right? That's a positive residual. A negative residual like Gabon was down here, right? It was below, right? So that's a negative residual. And in general, half the points are above and half the points are below. That's how it works, right? So this would mean the actual residual, or the actual y value, is below the line. Now, in the case of life expectancy, positive is good and negative is bad, right? But that is not always the case. So that's a warning to you. So I just wrote up that warning for you. It really depends on what your y variable is. So positive or negative residual for that matter, can be positive or negative. It can be good or bad. It really just depends on your context, right? So for example, in this case with life expectancy, positive is good, negative is bad, right? But what if it was crime rates? What if your town or city has more crime than you expect, right? Well, that would be a bad thing, right? So it really just depends on your context. I just realized I had an extra Y in there for no reason. So if you have life expectancy, positive is good, but if you have crime rates, positive is bad. And you'll have to read through the problem and kind of understand your Y variable to make that determination for a particular problem. So it's just something to keep in mind that it will change from problem to problem. And you'll have to think about it in the real life context and what the implications of the residuals are.